Good morning, ladies and gentlemen. Welcome to the final day of Africa's biggest energy conference, the African Energy Week 2024. It's been a week of learning, unlearning, networking, and most importantly, sharing knowledge on how to grow the African energy sector. My name is Wukosi Mashele, and I'll be your MC for today's proceedings. Thank you so much for joining us, and thank you so much for being here and believing in the power of the African Energy Festival, African Energy Week. Our focus here at stage one will be on oil and gas exploration across various African basins. We'll dive into the latest research, technologies, and strategies that are shaping the future of this vital sector. Africa's vast resources have the potential to drive significant growth and energy security, and today's discussions will provide insights into unlocking that potential responsibly and, most importantly, efficiently. Ladies and gentlemen, without any further ado, I would like to introduce you to our first speaker for today. We have Mr. Matthew Plummer, who is a senior exploration geoscientist at TGS. And he will be presenting on Basins Without Borders, Angola's exploration potential consideration from the wider South Atlantic region. Ladies and gentlemen, please give him a round warm of applause.
It's got the pointer. Okay. Good morning, ladies and gentlemen. So in this presentation, I'm going to highlight the two Angolan basins that stretch across international boundaries offshore Angola. So I mean the Lower Congo and the Namib basins. So in order to establish views on prospectivity of these basins, we've been able to utilize numerous high-quality modern 2 and 3D seismic datasets listed here, stretching from the shelfal areas into the deep water. So this includes over 136,000 square kilometers of 3D and over 70,000 line kilometers of 2D data. Okay, if we first look at the regional setting of these two basins, we can see they are very different. So the Lower Congo Basin, part of the South Atlantic Salt Province, stretches from the Sergipe-Alagoas South Gabon pair in the north to the Santos Basin in the south. From this schematic evaporite thickness map, we can see the conjugate salt basins of Brazil, so it's Jequitinhonha, Camurushatiba, and Ricuri, appear similar in spatial dimensions, but salt is thinner on the West African margin. Now, our experience of working in these regions reveals that the imaging challenges are far greater on the African conjugate, and appropriate application of technology is vital to further exploration success. And to really consider basins without borders, we have to remember there is much to learn and apply from along strike regions that appear similar geologically, from where analogies can be appropriately utilized. The Namib Basin is very different to the Lower Congo Basin, comprising a narrow continental domain with little salt, restricted just to the northern area. It is completely different to its conjugate, the Santos Basin, so it really benefits from a full basin-wide analysis to identify sweet spots for the different play elements. We'll first look at the mature Lower Congo Basin in some more detail. On the left, we have a high-pass filtered Bouguer-corrected satellite gravity map that shows in the north, the Lower Congo Basin to exhibit a very wide zone of continental crust, with the ocean-continent transition clearly defined by a sharp boundary in the gravity signature. To the right, we have a regional 2D section from the basin. I should say this is highly compressed horizontally. That line is around 265 kilometers long. And again, we see that wide continental domain with mobile salt throughout. To the west, we see a large step up in the base salt, marking the ocean-continent transition, over which the thick, inflated salt is thrusted. If we now step in a bit more locally, we see from the simple basin outlines displayed on the map on the left for the Lower Congo Basin, including the deep water Congo fan, that it extends from Gabon through Congo and into Angola. The central map shows the distribution of salt across the basin and beyond, along with the dominant structural style. The pink region represents where salt is either thin and welded, or more appropriately for the inboard, where salt rollers exist in the extensional domain. The grey areas represent diapiric salt, along with the massive inflated salt in the outboard. To the right, we have an annotated column illustrating where the proven play elements are found in the section. Working from bottom up, we have the pre-salt source units and both carbonate and clastic reservoirs in the Synrift and Sag sections. These are proven in the shelfer regions of the Lower Congo Basin in Congo and Angola. Moving up section, we have Albion-aged clastics and more commonly carbonates of the Pinda play, proven in both Congolese and Angola's sectors of the basin. And moving shallower still, we have rich, oil-prone, upper Cretaceous to lower tertiary marine source rocks, well known to have charged many giant fields within the deep water setting of the basin. And above in the young stratigraphy, the Oligomycene deep water channel sands that are proven to be extremely productive reservoirs. Now, having such regionally extensive data sets across the international borders assists greatly in understanding the potential of this basin. To the left, labelled 1, is an example gross depositional environment map from the Middle Miocene, put together by Anderson and co-authors back in 2012. Now, I should say on this display, all fields are displayed, not just those reservoired in the Middle Miocene. If we look in a deep water setting off the present-day shelf, we can see fields are concentrated in confined channels with less success outboard, where these channels may terminate into fan systems. Now, this lower success outboard is also undoubtedly a factor of less drilling, where traps have been more challenging to image in the areas of complex salt. I should say so far really in the Lower Congo Basin, most of the traps drilled have been relatively simple sort of drapes of channel sands over salt cord anticlines. So the next step really is to move to these more complex zones to identify further potential. The Middle Miocene on the Congolese side of the border has had less success, but overall is less mature in terms of exploration drilling. So it's another reason why evaluating the basin as a whole makes for a better understanding of the geology, and this then in turn provides further thoughts and ideas to apply to this sector. On the right, label 2, we have an isopack of the post-salt section, with thins in red and thicks in blue. Now, all post-salt fields are overlain in black for visibility on this colour palette. And by joining across the international border between Congo and Angola and evaluating in a more holistic way, we can see the post-salt discoveries are located over the depot thick and around the fringes of it. In these areas, the post-salt marine source rocks are generally mature. Outboard and in areas where the section thins, post-salt source maturity becomes a significant risk. But nevertheless, outboard in Angola and in Congo, where the post-salt section is thinner, we do find post-salt reservoir hydrocarbons. In deep mini basins, post-salt source rocks may have reached maturity, but we also may be reliant upon pre-salt charge, so understanding the deeper stratigraphy and structure is essential. So let's have a look at some examples of where we've been able to gain understanding to apply to other areas of the basin. This is a recently reprocessed line from the Congolese sector. Considering this data was acquired with just 4 to 4.5 kilometre long streamers, I think you will agree the imaging of the submobile salt sections is impressive. Now that we can image it well, these sections, we can look at other parts of the basin where similar complex salt is present and consider targets to explore further in a highly productive basin. This is another section from the same reprocessed data set, showing a well-imaged pre-salt section. With these data, we can now really think about ideas of hydrocarbons migrating from pre-salt source rocks to post-salt reservoirs, and look further afield within the basin, considering similar concepts. Now, this is an example line from the Angola mega survey. So that's a phase and amplitude matched merged product incorporating numerous legacy data sets through an area of the deep water Lower Congo Basin. Now, what we can see on these data, despite the more complex salting places, is signal within the pre-salt section, but improvements are needed here to evaluate those deeper plays, especially in the outboard. And this is exactly what we're looking to do with the Angola Vision product, a reprocessing of legacy acquisition over blocks 33 and 34 in Angola that has just commenced. This project will take the data from field tapes through a modern broadband processing flow to deliver depth products that improve understanding of that deeper geology. And again, to improve imaging and understanding of the deep section of the Lower Congo Basin, we are near to completing a reprocessing project on the Block 16 geostreamer data acquired in 2013. On this original line, on the left-hand side, we have identified rafts containing prognosed oligocene clastics that are better imaged on the neighbouring Block 114 dataset and are viable exploration targets within the basin. With the application of new processing technologies, we expect significant uplift in this data set. And to finish on the Lower Congo Basin, I'll summarise the acreage opportunities that currently exist. ANPG announced an update to available opportunities yesterday, so permanent offer blocks 32 and 33 are no longer open. But 34 is available for direct negotiation with the Angolan concessionaire. They also have marginal field development opportunities that are available within the basin. So yeah, these are exactly that, proven discoveries for appraisal and development. And on the Congolese side of the basin, direct negotiation opportunities are available for a number of blocks in the shallow and deep water, as listed here. Now we'll now look at the Namib Basin, which is markedly different to the Lower Congo with its narrow continental domain and much lesser extent of salt. On the left-hand side, we have again that high-pass filtered Bouguer-corrected gravity map. And what you can see down in the south there in the Namib Basin is a very large gravity high that has been interpreted to mark the ocean-continent transition. So a much sort of narrower continental domain. Within the seismic section, it's night and day really to the Lower Congo Basin. No salt on this line, very little salt in general, and it's not as structured, but it does have a significant thickness of post-drift section. If we take a quick look at the exploration history of the Namib Basin, so it's very much frontier territory, with only 4 wells drilled to date. So in the Namibian sector of the basin, 2 wells have been drilled, with the first being Kunini-1 in 2008, which had indications of gas. Chariot's 1811-5-1 well drilled the Tapir South prospect in 2012 and was declared as a dry hole, but did find excellent quality reservoir sands in the Cretaceous. And by looking at the data and looking at that well, we've established that's within the upper Cretaceous section. So these are a lot of these deep water channel fan plays that are being targeted within the South Atlantic realm. And it also penetrated an immature Cenomanian-Turonian source rock. ODP well 1080 was drilled in the south of the Angolan offshore in current block 45. Now this only penetrated 52 meters of recent section, so it's much less useful to the hydrocarbon explorers than other ODP and DSDP wells around the world. And the first exploration well drilled to date in the Angolan sector, Arcturus 1, was reported at this event on Monday to have reached TD by the operator ExxonMobil, and we look forward to hearing of the results in the near future. So to review the hydrocarbon potential of the Namib Basin, we've utilised wide-ranging, modern broadband 3D database acquired between 2014 and 2021, covering over 35,600 square kilometres. Being a frontier basin, observations from the seismic data are the key to develop a view on the potential. Now let's first consider source rocks. So this is a south to north strike line through the southern part of the Angolan sector of the basin. Now in this section we see widespread soft top tramline seismic events which could be marine source rocks deposited over an extensive area in flood events. These show clear AVO class 4 responses and are not dissimilar to Albion, Cenomanian, Turonian source rocks penetrated elsewhere in the South Atlantic. And when I say widespread, these are really extensive. So one event that I've looked at on these data sets, been able to easily map over an area of around 17,000 square kilometres. So extremely extensive packages. This line is again oriented south to north from further south in the Namibian sector. And here we see a continuation of these potential marine source units along strike in the basin. And here on a west-east line, we see those potential source units in a dip orientation, stacked vertically, laterally extensive, and draped over structure that could help to migrate hydrocarbons vertically through the section. So we've seen that we can identify potential source rocks on the seismic data within the basin, very frontier basin. Now what about reservoir potential within this post-drift section? So this composite line of the 3D surveys, again horizontally compressed, very long distances from south to north through the Namibian into the Angolan sector, say in both countries. And what we see throughout this section are very much interpreted clastic systems, likely of Upper Cretaceous to Lower Tertiary in age. So similar to what the Tapir Southwell Upper Cretaceous sands well developed down in the Namibian sector, more towards the inboard. What you can see on the Angolan side, we have very much more some more isolated possible clastic package systems within a dominantly maybe a shaline matrix. And down in the Namibia section, we have very much amalgamated sands, so large volume plastic systems. And continuing our view of potential reservoirs, we can look at these spectral decomposition RGB blends of the post-drift section. So if we first focus on the image on the left, shows clear channel belts within those interpreted clastic-rich fairways that we saw on the seismic sections. On the right of that image, looks a well-confined deep water slope channel system. And these are very similar to what we see within the tertiary section of the lower Congo basin, very much highly confined channel systems. And on the right of that image, on the left, we see details of these individual channels that amalgamate into a larger belt. Now these type of features extend throughout the section, clearly deflecting around volcanic structures that exist in the basin, as that can be seen on the image on the right-hand side. So to summarise where we see the potential in the southern Namib Basin, we can talk through this section. Okay? So it clearly shows the post-drift play concept nicely. So we see widespread marine source rocks, as I say, characterised by class 4 AVO behaviour, soft-topped clastic systems, quite often type 2, type 3 AVO response, draping deeper structure, and a thick package of interpreted shale providing a regional seal to the fairway. What we also see beneath that clear sort of clastic package is we see more isolated amplitude anomalies. So we could see these isolated clastic bodies encased in effectively source rock within the basin, which has been so successfully explored for elsewhere in the Atlantic thinking about the Guyana petroleum system, for example. So to finalise on the Namib Basin and consider acreage entry opportunities, ANPG have opened for direct negotiation blocks 11, 12 and 13 within the shelfal area of the basin, along with deep water block 43. So to summarise, geological basins rarely stop at international borders, and evaluating these in a holistic manner provides great benefit in identifying sweet spots for future exploration. Learnings can be applied cross-border and applied back and forth to de-risk play elements and identify the potential. The Lower Congo Basin has so much more to offer the explorer. As I said, post-salt source rocks in the deep water have so far been the dominant petroleum system to chase, but they are not mature everywhere. And looking to the deep is that next step, considering pre-salt source rocks, potential pre-salt reservoirs as well. And evaluating the areas where the imaging is good in a complex basin can provide input to de-risk the deeper section of other areas. We just need to translate learnings into other areas, demystify the complexities to reveal the true exploration potential. And the frontier Namib Basin that demonstrates significant exploration potential, and employing an observation approach lends itself to complete basin-wide evaluations. And I think this is the key point. If we focus and commit to understanding the potential of just one country or one block within the basin, especially in this frontier territory, we might just miss the opportunity to open the next super basin. Thank you very much for your time.
Any questions?
Thanks, Matthew. In the outboard Lower Congo fan, with the reprocessing just kicked off, I think 33 or 34.
Yeah.
In that kind of complex salt play, do you think the new operators of 32 and 33, I guess if they're off the table, do you think they'll seek to reshoot to get MAS imaging? Do you think that's needed?
I mean, certainly what we see in other areas of the basin, if we think of a stepwise approach, if we go just with the legacy data, yeah, it's extremely difficult. We've seen in the Congolese sector that improvements can be made, significant improvements with the legacy data. I think that's certainly probably the first step. If we think about incremental approach, if we can then improve the imaging, sort of high grade the specific areas, we've got to consider here, we end up talking about very large blocks. And so if we get, that can be that sort of step approach, identify an area, then consider some longer offset, new acquisition. Ultimately to drill, probably it's necessary, but I think going in at that high end very early on is probably going to be a significant area, significant cost. But yeah, of course, if we get this processed with the new workflows, it can then very easily, or in a generally easy sense, be amalgamated into a MAS system, a MAS product. Of course, the complexity of the salt basins, you never really know what the best orientation to acquire is, what's sort of perpendicular to the salt front. These things are very, well, fluid. And so I think the greater depth, the greater sort of extent of data, more options, yeah, the explorer would always want. But I say, certainly to focus in on where those areas might be worthy of new acquisition. I'm pretty certain this reprocessing, based on what we see in the neighbouring blocks, things will be of very high value.
Thank you so much. Any other question for for Mr. Matthew? Going once. going twice. Thank you so much, Mr.
Okay.
Plummer.